Hello there, our esteemed viewers. You're welcome once again to our favorite mathematics YouTube channel, Mathematics by Abu Zainab. The channel is specially created for you and I to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. I'm pleased to appreciate you for staying tuned all this while. Thank you for being true to us, because without you, we won't be here. Today, which promises to be another interesting class, we continue on our series of quadratic equations. We are taking it a notch higher today by looking at this example on the board, which states that given that alpha and beta are the roots of the quadratic equation minus 2x equals 4 plus 3x squared, we are to form the quadratic equation in x, whose roots are, number 1, alpha plus 1 and beta plus 1. Number 2, alpha squared beta and alpha beta squared. And number 3, alpha over beta and beta over alpha. This is a follow-up from our previous lessons, precisely the video that talked about forming a new quadratic equation from existing roots. And the emphasis on that lesson is that to form a new quadratic equation, if you are given two roots, all you need to do is to insert the sum and the product of the given roots into an established equation, which is x squared minus the sum of the given roots times x plus the product of the given roots equals 0. So by default, all you need to do is to find the sum and the product of the new given roots and then substitute into the customized equation. So let's see how it pans out with this set of questions on the board. I enjoy you to please sit back, focus, and enjoy. So here, to start with, the quadratic equation given is not yet in the standard form. Remember, the standard form has to be ax squared plus bx plus c equals 0. So we have to rewrite the question as 3x squared plus 2x plus 4 equals 0. This is the standard form, from which we can pick our a to be 3, our b to be plus 2, and our c to be plus 4. Thereafter, we go to the basics. What's alpha plus beta? Which is minus b over a. And we have minus 2 over 3. Then again, what is alpha beta? Which is the product? That is actually c over a. That is 4 over 3. These are the default settings for everything we are going to do. So if we are asked to now find the quadratic equation in x, those roots are, for question 1, alpha plus beta 1 and beta plus 1. All we need to do is to say, okay, what is the sum in this case? So you have alpha plus 1 plus beta plus 1. This is the first root and the second root. So the sum will be alpha plus beta plus 2. Thereafter, we can pick our alpha plus beta from here, which is minus 2 over 3 plus 2. And of course, we can solve this simply, which gives us minus 2 plus 6, which is 4 over 3. That's the sum of this new set of roots. On the other hand, what's the product? The product will simply be alpha plus 1 times beta plus 1. And on expanding that, I'm going to have alpha beta plus alpha plus beta plus 1 by simply expanding, just like algebra. So you have alpha beta from here is 4 over 3. Then plus alpha plus beta is minus 2/3. So you have minus 2 over 3 and plus 1 over 1 being a fraction. So simplifying, I simply have the LCM as 3. That will be 4 minus 2 and plus 3. So 4 minus 2 is 2 and plus 3 is 5 over 3. So you have 5 over 3. So what we have done here is to compute the sum and compute the product, which in summary gives us 4/3 and 5 over 3. So all we need to do now is to slot in or substitute these values 4 over 3, 5 over 3 into the customized equation. which, if you have not forgotten, is x squared minus the sum of the roots times x plus product of the roots, all equals 0. So from our last sum, we had 4 over 3x, and the product 5 over 3 equals 0. And don't forget from our previous lessons that it's best to always have integer coefficients by clearing fractions. Then we multiply through with the LCM of the denominators, which in this case is 3. So multiplying through by 3, I'm going to have 3x squared minus, so multiply 3 by 4 over 3, we're going to have just 4x, plus multiply 3 by 5 over 3, having just 5. So the answer is actually 3x squared minus 4x plus 5. So that's basically is the new equation to be formed with the root alpha plus 1 and beta for plus 1, which I believe you found quite straightforward. Without wasting much time, let's go straight to number 2. For number 2, the roots now are alpha squared beta and alpha beta squared. Just like the previous example, we write sum. The sum is alpha squared beta plus alpha beta squared. And remember from our last class that everything we do must revolve around sum and product. That is alpha plus beta and alpha beta. So if you have any expression that is not in that form, find a way of extracting the sum and or product from there. Hence, we have here as alpha beta factorized, then alpha plus beta. So I have been able to extract sum and product from this given sum. So alpha beta is 4 over 3 times, that's the product. Alpha plus beta is minus 2 over 3. So the product here is minus 8 over 9 for this product. Minus 8 over 9. What then is the product really? So the product of the same roots there will be alpha squared beta times alpha beta squared. And that gives alpha cube beta cube, which in other words is alpha beta all cube. That's indices, alpha beta all cube. Then what's alpha beta is simply 4 over 3. Hence we have here 4 over 3 all cube, which results in 64 over 27, because 4 cube is 64 and 3 cube is 27. So in this case, the sum amounts to minus 8 over 9, and the product is 64 over 27. And the next thing we do is to substitute this sum and product respectively in the appropriate positions. Minus 8 over 9 and 64 over 27. Remember, is x squared minus sum x plus product equals 0. So you have x squared. The sum was minus 8 over 9x, and the product was 64 over 27 equals 0. Basically, that's it. The only thing left now is to multiply through by the LCM of denominators. The LCM being 27. The LCM of 9 and 27 is still 27. Multiplying through by 27, I'm going to have 27x squared. Of course, remember, minus times minus here is plus. So 9 in 27, that will be 3 times 8, 24x plus 24, 27, 27 is 1 times 64, 64 equals 0. And that is the new quadratic equation to be formed, given the roots alpha squared beta and alpha beta squared. It's quite straightforward, really. Let's take the last one to cap it off. So we have here that this time around, the roots are alpha over beta and beta over alpha. So don't forget that all you need to do as usual is to compute the sum and the product. The sum here is alpha over beta plus beta over alpha. Remember, again, there's nothing as sum and product directly here yet. So we need to simplify further to extract the sum and the product of alpha and beta. So we have the LCM being alpha beta. Beta in alpha beta is alpha times alpha, alpha squared. Alpha in alpha beta is beta times beta, we have beta squared. Remember from our previous video that alpha squared plus beta squared simplifies to alpha plus beta all squared minus 2 alpha beta all over alpha beta. So the numerator alone is all this. So you can see clearly that, okay, we now have expressions in terms of sum and product. So we go ahead and add, or we substitute rather. So we have minus 2 over 3 all squared, then minus 2, 4 over 3 divided by alpha beta is 4 over 3 still. So this is alpha plus beta all squared minus 2 alpha beta over alpha beta. So when we simplify this, we are going to have 4 over 9, that's minus 2 over 3 all squared, then minus 8 over 3 all divided by 4 over 3. So on simplifying this numerator, the LCM of course is 9. We're going to have 4 minus 3 9 is 3 times 8, 24 over 4 over 3. So this gives us minus 20 over 9, of course, times 3 over 4. When we invert this, divided by 4 over 3 means times 3 over 4. So when we simplify for that, I'm going to have 4 in 20 is 5, 3 in 9 is 3. So the sum at the end of the day becomes minus 5 over 3. You can keep that somewhere, minus 5 over 3 as the sum. So let's have the product. The product of the same root becomes alpha over beta times beta over alpha. That's the product, as simple as that. Interestingly here, this actually crosses out, and that becomes 1. The product is 1. In other words, the sum is minus 5 over 3, and the product is 1. Without wasting time, let's just insert directly into the equation, which is x squared minus sum x plus product equals 0. So we have x squared minus the sum is minus 5 over 3 x, and product is 1. And again here we have our fraction, so we linearize. So we're going to multiply 3 by 3, and that gives us 3x squared plus 5x plus 3 equals 0. And that is the solution to the last question there, which is about the very last one for the day. And I believe you found this part of the series quite interesting and quite very insightful, and most importantly fun. And we just have come to the end of the video for today. So the lesson today has been how to construct a quadratic equation in a given variable, in this particular instance x, with given roots, which is more or less an extension of our videos in the last lessons. I believe you found this lesson quite insightful, educative, most importantly fun, as much as I did. If you do, please don't forget to subscribe, share, like, and of course, put on your button so that you'll be the first to know when next our video drops. And that's going to be on discriminants. What exactly is discriminant? Stay tuned for the next video for that. Thank you and stay blessed.